Hello everyone, I am Umashankar, a computer science undergraduate at the Indian Institute of Engineering Science and Technology, Shibpur. Today, I am excited to share what I have learned during my 1 month virtual internship with Emergze Information Technologies, where I work on exciting embedded systems project, a washing machine simulator using the PIC16F877A Microcontroller. Here's a quick overview of what I will cover in this presentation. From an introduction to embedded systems to the architecture, microcontroller programming, peripheral interfacing, and finally a walkthrough of my project. I will also reflect on key skills I gained during this journey. My internship was conducted virtually from May to June at Emertxe, a reputed name in embedded systems training. The goal was to gain practice exposure in microcontroller programming and interfacing real world components like LEDs, LCDs, Keypad, and more, all centered around a project that simulates a washing machine controller using the PIC 16F877A microcontroller. This slide talk about the objective of this internship. This internship was designed not just to teach but to immerse us in the real workflow of embedded system design. I had specific learning goals during this internship that are understand how microcontrollers like the PIC16F877A are architected and programmed, interface real world components to a microcontroller, simulate a working washing machine with modes like quick wash, heavy wash, and spin, and lastly, sharpen my debugging and optimization skills, which are crucial in embedded programming. This slide explains about the building blocks of the project. To build the simulator, I used a toolchain that included MPLAB X IDE, the X8 compiler, and Picsimlab, which let me simulate the test and hardware virtually. The microcontroller at the heart of this project was PIC16F877A, an 8-bit chip with onboard flash RAM and EPROM. This allowed us to write, compile, and simulate code before deploying it. I also worked with key hardware components such as 4x4 matrix keypad, tactile switches, 16 into 2 character LCD, buzzer, motor, fan, motor that is simulated as fan here. The next slide. From here, the further slides will explain about the core concepts I have learned during this internship. Uh, One of core skills I developed was embedded C programming. Here you can see I have uh, explained what is embedded C in brief. Let's see. Embedded C is a specialized extension of programming language optimized to microcontroller based systems. Unlike standard C, it focuses on direct hardware control, resource efficiency, bare metal programming. The next slide, it talks about embedded system. What is an embedded system? An embedded system is a dedicated computing system designed to perform specific tasks within a larger mechanical or electrical system. Unlike the general purpose computers, it is optimized for efficiency, readability, and real time operations. It doesn't require an operating system. Uh, For example, my washing machine simulator reacts in a real time when a user selects the wash mode. That's embedded in action. The further slides will explain about the types of embedded system. Throughout the internship, I also explored various types of embedded systems. First one, a standalone embedded system. The, the function of the standalone embedded system is it operates independently without a host computer. Examples are digital watches, calculators, microwave ovens. The key traits is no external communication interfaces. Second one, real-time embedded system. The real-time embedded system can be defined the system where every second matters, such as in cars or medical devices. The real-time embedded system is further divided in two other types. First one, hard real-time embedded system, where missing deadlines causes failure, like medical ventilators, airbag system. And second one, software real-time embedded system. It can tolerate minor delays like streaming devices. Third one is network embedded system. The function of this type of embedded system is communicate that is it communicates via wired or wireless networks. The protocols used in this type of embedded system TCP, IP, ZigBee, LoRa, Bluetooth. Examples are smart home devices like Wi-Fi thermostats, industrial IoT sensors. The next one, mobile embedded system. The function of this type of embedded system is that it is portable with battery power constraints. Examples are fitness trackers, drones, handheld barcode scanners. Its design focuses on low power consumption, compact size. Last one, and a hybrid embedded system. Hybrid embedded systems such as Tesla's autopilot, understanding these types help me better place my project in the category of standalone plus real time. The next slide talks about microcontroller. What is a microcontroller? A microcontroller is a compact self-contained computer system on a single integrated circuit. It is designed to control specific tasks in embedded systems by integrating a processor, memory, and programmable I/O peripherals. A microcontroller like PIC16F877A is essentially a small computer on chip that is defined in microcontrollers definition. It takes input from sensor or user interfaces, processes logic coded in embedded C, and gives output signals to control devices like motors or LEDs. In my case, it controlled the full sequence of wash, rinse, and spin in the simulator. The further slides will explain about the peripherals used in washing machine project. In my embedded project, interfacing peripherals is crucial. I interfaced CLCD, that is character liquid crystal display, This is used to display system information such as current wash mode, water level, and timer countdown. It is operated in 4-bit or it can operate in 4-bit or 8-bit data mode to send commands and character data to the display. It helped me in debugging and the improving the project. With next next peripheral was keypad. Act as a main input interface for the user to select wash modes, water level, and to start or stop the washing cycle. Uh, Third one is buzzer. It gave audio feedback like alerts or end of cycle notification. Next one, LEDs indicated different stages of washing, rinsing, and spinning. Last one, fan represented the spinning action in real washing machines. Each peripheral added a layer of functionality and realism to the simulation. Now, before going further, I would like to show my project demo. First, I would like to show the code used in this project. Here you can say these are header files of code and these are source file. Here you can see there are 5 header files used in this project and there are 6 source files. Now let's go to Picsimlab to show the demo of the project. Here you can see the hex files I have loaded. Let's reload it. Yeah. Here you can see it is displaying press key 5 to power on washing machine. Let's press key 5. Here you can see washing machine has on. Here the different washing programs. To scroll through the washing programs, I have to press key 4. Here you can see the different washing programs like whites, stain wash, eco cottons, woolens, bed sheet, rinse and dry, only dry wash only. Let's select wash only. For selecting a washing program, I have to long press the switch number 4. Let's select. Here I have selected wash only. Now it is showing to select water level. There are different water level options: low, auto, medium, high, max. Let's select low. Same select for selecting, press switch number 4 for a long time. Here it is showing that to start washing, press switch number 5, or for stop, press switch number 6. Let's start the washing. Here the time is showing 16 seconds. To start, press 5. To pause, press 6. Let's press switch number 6 to pause the washing. Here you can see the washing has paused. To continue, let's press the switch number 5. I have pressed switch number 5. The washing has started. When the timer will be end, it will show that program completed. Remove the cloths and again it goes to the washing program. This is all about project. Let's go to the further slides. The conclusion of this internship. This internship transformed my understanding of embedded systems for theory to real world practice. I mastered embedded C and use of PIC microcontroller. I successfully built a working washing machine simulator and I got hands on experience debugging real time issues, designing state machines, and integrating hardware. Most importantly, I gained the confidence to take one more complex embedded challenges in the future. I would like to thank Emerging Information Technologies, especially my mentor Guhapriya S. Ma'am, for her patience and support. The mentorship and guidance I received helped me understand complex concepts like timer interrupts and peripheral interfacing in an accessible way. This internship was a crucial stepping stone in my journey toward becoming a system engineer. This was all. Thank you, guys.